Okay, so we're back. So looking at example number 3, describing a possible situation for a graph, we want to take a look at this graph and we want to think about what's going on in each of these sections of the graph. This describes a day trip from Winnipeg to Winkler, Manitoba. So we got up in the morning, we live in Winnipeg, we're going to drive to Winkler, hang out for a little while, and then come back. So we want to think about exactly what's going on in each of the sections. Now, as you can see on the graph, there we have O to A to B to C to D and E. So we're going to think about exactly what takes place in each of those sections. So in the first section, OA, we from O to A, we drove 1 hour and we covered 65 kilometers. So this is the first leg of our journey. Then we have this little tiny flat spot, AB. So we aren't changing our distance at all, but time is passing. So basically we've stopped for about 15 minutes. If we look at our graph at the bottom, it's we stopped for, it's not a full, it's like for about a quarter of an hour. So maybe we pulled over to the road, we stopped, we had a little break, maybe we stretched our legs, and then we got back in the car, and from B to C, we drove another 45 minutes, and we went another 65 kilometers because we are at about 65 kilometers at B, and we're at about 130 kilometers at C. Now then there's a big flat plateau from B or C to D. So CD. So here we don't change our distance at all, but 2 hours pass. So we have a 2 hours pass and we've stopped. No distance. So this is when we're in Winkler. So here we're here for our trip. Maybe we visit some of the sites or we visit our friend that we've come to meet for lunch, but we don't really move with the vehicle. Then from D to E, we, as you can see, our distance is going back towards where we started from. So we don't stop. We drive all the way back. We go the full 130 kilometers in 2 hours. No stopping. We just drive all the way back. So that's what's going on. You can think about what you did at each of the legs, but really that's basically what's going on in that map. Now, if we're doing the opposite, where we are sketching our graph based on given situation, we have to take a look at how do we graph this. So here's our example. Samuel went on a bike ride. He accelerated until he reached a speed of 20 kilometers per hour. Then he cycled for 30 minutes at approximately 20 kilometers per hour. He arrived at the bottom of a hill and his speed decreased to approximately 5 kilometers per hour for 10 minutes as he cycled up the hill. He stopped at the top of the hill for 10 minutes. Sketch the graph of speed as a function of time. So we're graphing speed versus time. Okay, so that's what we're going to start with. So on the bottom of our graph here, we have time, and we're going to put it in minutes because there's a lot of talk of minutes here. Then on this side, we have speed. And here we're going to do it as kilometers per hour because if you look, that's what it's given to as this. Okay. Now, we'd often put in a title as well, Samuel's bike ride. And it is time versus speed. We always want to give a title. And then we want to think about what's going on. Now, starts here. A, let's put in some units. 10. Oops, that's not really a... Okay. Maybe I can use my ruler. That's good, eh? Okay. Here we go. So 10, 20, 30, 40, 50, and then my speed, same thing. Aren't I nifty? And 5, 10, 15, 20, 25, 30, 40. Okay. And then I'm going to get rid of that. So we're looking at our time, 10, 20, 30, 40, 50, and our speed, 5, 10, 15, 20, etc. And then we're going to graph this. So first it says he accelerated till he reached a speed of 20 kilometers per hour. Then he cycled for 30 minutes at approximately 20 kilometers per hour. So very quickly he accelerated till he got to 20 kilometers per hour. We don't know exactly how long it took him. So that's our first step. So this is B. Then it says he cycled for 30 minutes at approximately 20 kilometers per hour. So at approximate 30 minutes, so that's our C. Then he arrived at the bottom of a hill and his speed decreased to approximately 5 kilometers per hour for 10 minutes. So when he hit that top of the hill, he slowed right down to 5 kilometers per hour. So we'll call that D. And then it says he cycled up the hill for 10 minutes. So that got him to there. And then he stopped at the top of the hill for 10 minutes. So when he reached the top of the hill, he stopped. He was out of breath. And he rested for 10 minutes at the top of the hill. So if we look at all of that, that means that here is our first section from AB. Then we have our second section, BC, where he's cycled for 30 minutes at 20 kilometers per hour. When he reached the bottom of the hill, he slowed right down, so that is going to be DE. And then when he stopped at the top of the hill for 10 minutes, he rested, and that's FG. Now there's other sections where he's slowing down but that is basically our map. Okay. In general, if we're looking at a time versus speed, constant rate of change, time versus speeds going up. Rate of change is not constant. We're going to see more of a curve or changes in the graph. No rate of change is going to give us a flat line. It stays the same. All right. So that's our first lesson. It's a lot of interpreting graphs. Your homework is in your textbook, page 274, 1 to 4, 7, 8, and 10. You can always do extra questions if you'd like. I might also pop in some review material from grade 9 to help you out.